On this Ram 1500 with the 5.7 Hemi P0302 means the PCM is seeing a cylinder 2 misfire pattern. The driver may feel a rough idle, a stumble under load, reduced power, or a flashing MIL if the misfire gets severe. Broadly, this can come from ignition, fuel delivery, air or vacuum issues, engine mechanical problems, oiling or valvetrain concerns, VVL operation, wiring, or in the last part of the path, PCM control. The key is not to jump straight to a part. Start with the basic system checks, then prove whether cylinder 2 is actively misfiring under the same conditions that set the code. Before chasing the fault, make sure the monitor had a fair chance to run. The gate is fuel level above 12%, battery voltage above 9 volts, ambient temperature above -23 degrees C, -9, 4 degrees F, coolant temperature at engine start above -7 degrees C, 19, 4 degrees F. And if the start temperature is below threshold, the monitor enables when engine temperature reaches 21 degrees C, 69, 8 degrees F. Engine speed also needs to be between approximately 400 RPM and 6,200 RPM. Then turn the ignition on, pull the stored codes, and record the captured operating data. Drive or operate the vehicle under those captured conditions and watch when the misfire shows up, because that detail matters later. While the misfire is happening, watch the downstream oxygen sensor behavior and the misfire monitor, or you can confirm whether cylinder 2 is the cylinder with excessive counts right now. A consistently low downstream oxygen sensor signal points you toward a lean or lack of fuel direction, while a consistently high signal points toward excess fuel in the catalyst, which can happen with loss of spark or a leaking injector. Also remember that during a severe misfire, the PCM may shut off the affected injector for catalyst protection, so a high-load misfire can appear to continue briefly when the engine comes back to idle. If cylinder 2 is not actively showing excessive misfires, treat it as an intermittent and do not force the rest of the pinpoint path. Next, look at the other recorded codes without turning this into a code list. If fuel system, ignition component, air handling, VVT, or VVL codes are active or pending, diagnose those first because they can be the reason cylinder 2 is misfiring. If those supporting systems are not pointing you somewhere else, move into the physical inspection. Look for crankshaft speed disturbances and basic engine problems, belt or accessory drive issues, sensor mounting problems, poor terminals at key engine components, PCM power and ground corrosion, vacuum leaks, air inlet or exhaust restrictions, internal engine concerns, moisture on ignition parts, fuel level or fuel quality concerns, and overload type operating conditions. If you find a problem here, fix that condition and verify the repair before moving deeper. If the inspection does not find the fault, check the engine and intake manifold for vacuum leaks. A leak can affect one cylinder or several cylinders depending on where it is, so do not assume it has to be a global lean problem. If the intake system is sealed, check fuel quality next. Look for water in the fuel, wrong fuel type, old or contaminated fuel, and low fuel, then perform the ethanol level check. If the fuel is the problem, correct the fuel condition, flush and clean the fuel system if needed, and then verify the repair. Now move to the injector test. Use fuel pressure decay tester 8978A at the fuel rail. Before opening or servicing the fuel system, release fuel pressure. The system can stay pressurized even with the engine off, and mishandling it can cause serious injury. Key on. Let pressure build and stabilize, and record that as the starting pressure. Actuate the injector for cylinder 2 while watching the gauge, then record the ending pressure. After each injector actuation, start the engine to clear fuel from the cylinder. Skipping that can damage the engine. Repeat the same test on several known good cylinders, always beginning from the same starting pressure, and compare the ending pressures. If cylinder 2 drops about the same as the known good cylinders, continue to ignition testing. If it stands out, a small drop sends you toward debris in the fuel rail or injector, while an excessive drop points toward a faulty or fouled injector. Repair what the test proves and verify the repair. Before continuing, remove the fuel pressure decay tool and reconnect the fuel lines. Pull the ignition coil from cylinder 2, plug the coil connector back in, disconnect the injector connector for that cylinder, install a spark tester and crank the engine. You are looking for a crisp blue spark. If spark is present, inspect the spark plug and the cylinder. Look for cracks, carbon tracking, oil, coolant, excess fuel, incorrect gap, or a loose or broken electrode. And also check for signs of oil or coolant in the cylinder. If one of those plug conditions is present, the path supports replacing the spark plug. If oil or coolant is in the cylinder, diagnose and repair that cause. If the plug and cylinder inspection do not show the issue, run compression on all cylinders and compare cylinder 2 to the known good cylinders. If compression is not within specification, follow with a leak-down test to separate valvetrain from combustion chamber problems. Repair the proven cause and verify the repair. If compression checks good, exchange the cylinder 2 spark plug with a known good cylinder that is not misfiring, or replace the plug if access makes swapping impractical. Start the engine and watch the misfire monitor. If the misfire follows the plug or goes away after replacement, the spark plug was the fault path and you verify the repair. If it does not move and does not go away, decarbon the valves and combustion chambers using MOPR combustion cleaner. Drive the vehicle to clear the cleaner from the engine, erase the codes, reproduce the captured conditions, and watch the misfire monitor again. If the misfire does not return, the carbon cleaning repaired the fault. If it does return, check engine oil level and condition, oil pressure concerns, filter correctness, viscosity, contamination, aeration, and related mechanical tolerances before going farther, because skipping that can lead you into a bad diagnosis. Then consider the VVL side only when the misfire pattern supports it. If the misfire happened when engine speed exceeded 5,000 RPM and VVL is suspected, check VVL operation and inspect the solenoid sealing before judging rocker arm operation. A rocker arm stuck in low lift can show up at or above approximately 5,000 RPM. If the available VVL information does not clearly identify the cylinder 2 hardware, pause, recheck the earlier diagnostic path, and do not guess. After that, visually inspect the camshaft lobes, rocker arms, and springs for excessive wear or broken parts, understanding that some of those failures may not always show up during compression testing. If the earlier spark test did not show a crisp blue spark, go to the coil electrical checks. With the ignition off, disconnect the cylinder 2 ignition coil connector. Turn the ignition on, command the ASD relay with the scan tool, and use a 12-volt test light connected to ground to probe the ASD relay F342 output at the coil connector. If the light does not illuminate brightly, repair the open or short to ground in that feed circuit between the PDC and the ignition coil connector, then verify the repair. If the feed is good, check the coil control circuit. Use a 12-volt test light connected to a 12-volt source. Back probe the coil control circuit at the coil connector and crank the engine for 5 seconds while watching the light. Stay clear of the fan, belts, pulleys, and loose clothing while cranking. If the light blinks brightly, the path supports replacing the ignition coil and then verifying the repair. If the light stays on constantly, check the control circuit for a short to ground. If it stays off constantly, check the control circuit for an open or high resistance. For a control circuit short to ground check, turn the ignition off, disconnect PCM connector C2, and use GPEC Diagnostic adapter 10436 on the engine harness side. Do not probe the PCM harness connectors directly, because that can damage terminals and create a poor pin fit. Check continuity between ground and the coil control circuit at the ignition coil connector. If continuity to ground is present, repair the short to ground and verify the repair. If there is no short to ground, continue to the final connector checks. For an open circuit check, measure resistance in the coil control circuit between the ignition coil connector and the diagnostic adapter. If resistance is not below 3.0 ohms, repair the open or high resistance and verify the repair. If it is below 3.0 0 ohms, inspect the related PCM, inline, and component connectors. Look for poor seating, damaged locks, corrosion, water intrusion, whether seal damage, bent or pushed back terminals, overheating, spread terminals, and terminal tension problems. Repair any connector or harness problem found. Fully seat and lock everything. Erase the code, reproduce the monitored conditions, and read codes again. If P0302 returns after those checks, the path supports replacing and programming the PCM, then verifying the repair. If it does not return, the wiring or connection problem has been repaired. The takeaway on P0302 is simple. Prove the active cylinder 2 misfire first. Use the scan data to choose the right direction and work through air, fuel, spark, compression, carbon, oiling, valvetrain, and coil control in order. Keep verification separate from testing and only call a part bad when the branch proves it. For more diagnostic training, visit stepdiagnostics.com.